Example 3. Find f if f prime of x is equal to e to the x plus 20 times the quantity 1 plus x squared to the power of negative 1, and the fact that f of 0 is equal to negative 2. Okay, so let's take a look at the general derivative of this function. So we know that f prime of x is equal to e to the x with 20 in the numerator here. And since the quantity is raised to the negative power of 1, it's going to be over 1 plus x squared to the first power. Okay, and so what we know here now is we can rewrite this in terms of the following. We have f prime of x, which is equal to e to the x plus 20 times 1 over 1 plus x squared. Okay? And so from here, it's a good idea to now look at the table for the particular antiderivatives. Okay? So we want to now find the antiderivative of this function. So in order to find the antiderivative of this function, we can use our table. So the antiderivative, so we're going to call this f since it's given here as lowercase f of x. Okay, so what is the antiderivative of e to the x? Well, we know it's going to give us e to the x plus 20 times, what is the antiderivative of 1 over 1 plus x squared? Well, we can see it's tangent inverse x. So it's tangent inverse x, and that's plus a constant c. Okay, so now we have the antiderivative. Okay, now in part 4, okay, we're given the fact that f of 0 is equal to negative 2, which means that x is 0 and f of 0 is negative 2. So now using this function, we can determine what the value of c is. Okay, so let's go ahead and plug in our value. So we know f of x is going to be negative 2. So it's going to be negative 2, which is going to equal e to the 0 plus 20 times the tangent inverse of 0 plus c. So we know that this is going to give us negative 2, which is equal to 1. And tangent inverse of 0 is 0, so that's plus 0 plus c. And if we want to solve for c, then we would subtract 1 to both sides and get negative 3. And so therefore, now that we know what c is, we can now rewrite this as f of x, which is equal to e to the x plus 20 times the tangent inverse of x minus 3, since we know what the value of c is. And therefore, there is our function. Okay, now let's take a look at what the graph looks like. Okay, so this is figure 2. Okay, so here we have the function f of x. So there's the function, and then there's its derivative. So it shows the graphs of the function f prime, which is in example 3 here, and its antiderivative f. Now notice that f prime of x is greater than 0, so it's above the x-axis. So f is always increasing. Also notice that when f prime has a maximum or a minimum, f appears to have an inflection point. So the graph serves as a check on our calculation.